All right, so here's our answers for today's Check Your Understanding. Mason never has a pencil when test day rolls around. Because the classmates are tired of having to supply pencils for Mason, only 15% of students will give Mason a pencil when asked. Today is test day, and Mason begins asking randomly selected students for a pencil. Let y equal the number of students Mason asks until he finds someone who will give him a pencil. We need to describe this probability distribution. Make sure to check the appropriate conditions. So we want to check, is this a geometric distribution? So I'm going to use that acronym BIDS to do that. So B still stands for binary. A success equals that Mason gets a pencil. Okay. A failure is that he doesn't get a pencil. Okay. For I, we're still looking at independent. Okay, and we know that the trials are independent. One person giving him a pencil does not affect the next person giving him a pencil or not. Instead of N, a set number of trials, now we have T, that like till thing. We are looking at the fact that Mason asks until he finds someone to give him a pencil. Okay. And then S is still the same probability of a success. And we know that P is equal to that 15%, 0.15. So ultimately, to describe this distribution, we can say that this is a geometric distribution. Part B asks, what is the probability that the third person asked is the first person who gives him a pencil? So we're looking at the probability of why someone giving him his pencil happens on the third person. So I'm using my binomial or my geometric formula, which we said was that we had 1 minus p raised to the x minus 1 times p. Okay. So 1 minus p, if p is 0.15, 1 minus p is 0.85. And if we want the third person to give him a pencil, that means 2 people did not give him his pencil times that success that someone did give him a pencil. And so when we do that, we get 0.1084. Okay. For part C, it says, what is the probability that Mason gets a pencil by the third person he would ask? So how is this different? Okay. Well, he could get a pencil on the first person, okay, plus the probability that he gets a pencil on the second person, plus the probability that he gets a pencil on the third person, okay? Which ultimately is going to come out to 0.3859, okay? I could write this in a different way, and really what I'm asking myself for is the probability that x is less than or equal to some number, in our case 3, okay? I can find this by going into my calculator in doing the geometric CDF for my probability 0.15 and my X value of 3 or my Y value of 3. So this would be the function that I'd use to get this number. Part D, how many people should Mason expect to ask before getting a pencil? So this word expect is our hint that we're being asked about the mean. Okay? Think mean, the average number of people he should expect to ask. So for a geometric distribution, the mean of y is equal to 1 over the probability. So in our case, that's 1 over 0.15, which is 6.67. So Mason should expect to have to ask 6.67 people before he gets a pencil. Part E, should Mason be surprised if Mason didn't receive a pencil until he asked 10 people? Calculate a probability to justify your answer. So we're looking at the probability of Mason asking 10 or more people, which would be 1 minus the probability of one person giving, the first person giving his pencil, plus probability of the second person giving him a pencil, so on, until we got the probability of the 9th person giving him a pencil. Okay. And so if we're thinking about how we can enter that into the calculator, similarly, we're ultimately looking at the probability of y being greater than or equal to 10 would be 1 minus the probability of him being less than or equal to 9. Okay. Thinking kind of in that number line, if I have 10, 11, 12, okay, and then 9, 8, 7, I just really need to know this probability. Okay, so I can do 1 minus that geometric CDF, where P is 0.15 and X is 9. And I get the answer of 0.2316. So is this surprising? Well, I have a 23% chance of it happening. So ultimately, I'm going to say no. Okay, it's not surprising, right? Because it's greater than that 5%. So we can say no, 0.2316 is not that unlikely to occur. Okay, you shouldn't be surprised about it. And then in part F, it says find the standard deviation for the geometric distribution of the number of people he asks for a pencil before finding someone who will give him one. Okay, so this is just using our formula for standard deviation of a geometric distribution, which is the square root of 1 minus p and the whole thing divided by p. So I have the square root of 1 minus 0.15, then divided by 0.15. And we get a standard deviation of 6.146 people. All right, so lots of new formulas that are all on your formula sheet, so not something you have to memorize. but just be aware of that change between binomial distribution and geometric distributions. If you have more questions, don't hesitate to ask in class.